Section 6.6 is all about trapezoids. Open up your notes, put this in your table of contents, and then start up with a fresh page. First, definition of a trapezoid. A quadrilateral is a trapezoid if and only if it has exactly one pair of parallel sides. So in this trapezoid, let's call it TRAP, I would know that, let's say TP is parallel to RA. Couple things. The sides that are parallel are called the bases. So maybe I'll call this base 1 and base 2. It doesn't have to be like that. You could have said maybe TP is base number 2, RA is base 1. Either way is just fine. The sides that are not parallel are called the legs. Again, maybe I call that leg 1, leg 2. So a couple of other definitions. A trapezoid is isosceles if and only if its legs are congruent. So here we have an isosceles trapezoid, MATH. I see MA is congruent to TH, and base MH is parallel to base AT. A few theorems included with isosceles trapezoids. If math is an isosceles trapezoid, then both pairs of base angles are congruent. And so that tells me that M is congruent to H and A is congruent to T. Another theorem associated with only isosceles trapezoids is if it's isosceles, then the diagonals are congruent. So if I ask to fill in the missing coordinates, here I have a trapezoid. The only given point is point O with coordinates A, R. Now notice the congruence markings. If I use point A, that indicates that this length, KC, is A units long. And so therefore the coordinates for point C, A0. Likewise, the height from K to R is also 0A. Here I have another trapezoid. This one happens to be isosceles. And so from the given coordinates, we can find the other 2 points, D and A. First, look at A. That indicates that the height of the trapezoid, the vertical distance, is A. And so if that's A units tall, A is also A units tall. Then, using the J coordinate, I know that that little length from J to that distance, that dotted line, that length is J. And because of symmetry, I know that that length is also J. Now the entire base length is S units long. And so the point where those two segments cross is going to be S minus J units long. And so therefore the x coordinate of point A should be S minus J. Oh, I guess D, I forgot D. D is 0, 0. Let's take a look at one more example. Here I have another isosceles trapezoid. This one sort of goes over the y-axis a bit, and so we've got a negative coordinate. I know that R is going to be M minus K, because M is the length from the origin to C, H is K units long. Now, let's say I've got this trapezoid yoga. It's not on a coordinate plane. It's not on an XY grid. All we know is that it has bases YO and GA. And so we must label them in a clockwise fashion. YO, G, and A. Now let's say that angle Y is 122 degrees. And I want you to find angle A, angle O, and angle G. Because bases are parallel, angle Y and angle A are consecutive interior angles. And so therefore, angle A and angle Y add up to 180. Angle A is equal to 58 degrees. However, I don't know how big O and G are. Since this is not isosceles, if it's strictly a trapezoid, then I know that O and G are supplementary, but I don't know their actual values. Second question, still dealing with this trapezoid, let's pretend that yoga is isosceles. Let's say we want to solve for x when the length yg is x squared minus 8x and OA is 9x minus 70. So YG and OA, those are diagonals. And if the trapezoid is isosceles, and we're saying it is, then the diagonals must bisect each other. And so then we would say YG must equal OA. So if the diagonals bisect each other, that means x squared minus 8x is equal to 9x minus 70. Now if you think back to your Algebra 1 days, whenever you have an x squared term and some plain old x terms, that indicates you're going to have to solve by factoring. So we're going to factor this trinomial. First, let's change this so it looks like a trinomial. I'll subtract 9x from both sides. I'll add 70 to both sides. And now we're looking for factors of 70 which sum to negative 17. I know x minus 7 and x minus 10 will do the trick. So then the first term, x minus 7, could equal 0. Or the second term, x minus 10, could equal 0. So I have two potential answers, x minus 7 or x equals 10. Those are the two algebraic answers, but are they geometrically legit? To check, we'll substitute x back into the original equations. Let's take x equals 7. If we use x equals 7, then yg is equal to negative 7 units. Well, that doesn't make any sense geometrically. And so therefore, even though x equals 7 is an algebraic answer, it is not geometrically possible. If instead we use x equals 10, then I get that yg equals 20. That seems to make more sense. Segments can't be negative, and OA is 20, so therefore that's geometrically legit. Our final answer is x equals 10.